Moving on to sediments, we've got a lot of information on sediment quality in the bay. One of the things that we've been keeping a very close eye on for some time is sediment particle size, or the particle size composition of the sediments in the bay. And again, we've got data from the 1970s, 1974 up to the present day. And what we're interested in is the relative proportions of mud, the very fine component, sand, which is a sort of particles around 1 millimeter or so inside, versus gravel, bigger than 2 millimeters in size. The relative contributions those elements make to the sediments that we collect from various sites around the bay. Now, we're collecting sediments from around 30 or I think 40 sites in the bay every year. I've just shown you a handful of stations. This is time series data for a handful of stations in Small Bay. And for most of these pictures, a very similar trend over time. Back in the 1970s, almost 100%, if not 100% of the sediment at those sites were made up of sand. Very, very low percentages of gravel or mud in those samples across all the stations back in the 1970s, before the ore terminal or the causeway linking Marcus Island with the mainland was constructed. We went through a very bad patch during the late 1990s through to the early 2000s, where you see that blue color creeping in quite extensively. And what that indicates is that levels of mud, the proportion of mud in the sediment, shot up to very, very high levels there, 80, 90% in some cases. And that meant that those sediments were largely dominated by fine particles, mud. It's very difficult for oxygen or water to penetrate the sediment when you've got high levels of mud, so those sediments become quite anoxic and quite unsuitable for marine organisms. The burrowing organisms live in those sediments. But we've seen a progressive improvement since the peak in 2005 or so towards the present day, where every year we see a progressive reduction in the amount of mud in the sediments. Now, that mud is mostly suspended through dredging activities, and we think that the extensive dredging that was done in the bay in the 1990s with the expansion of the ore terminal, with dredging of shipping channels, resulted in quite a massive increase in those levels of mud, and we've seen a very, very nice positive trend of reducing mud over time. So very nice to see, very encouraging, and we hope that continues. Similarly, levels of organic carbon and nitrogen in the sediment follow a very similar pattern to those fine sediments. We have a very small amount of data for some sites back in the 1970s with very low levels of organic carbon and nitrogen in the sediments, peaked in around the late 1990s to 2000s and dropping down again towards the present day. Very positive trend of reducing levels of carbon and nitrogen in the sediments across all the sites in the bay. We think levels peaked in this period, 2005, 2006. We had a lot of big fish processing plants in Saldanha Bay discharging fish waste from those fish processing plants into the bay, very high in organic carbon and nitrogen, combined with the inputs from the wastewater treatment works, were serving to push up the levels of organic material in the sediments, had a massive impact on the oxygen levels in the bay. But what we're seeing now is levels declining across all the sites. Very encouraging, positive trend. And another big smiley face there. Trace metal levels in the sediments, very similar to those that we saw with the marine organisms. I've got level information on levels of cadmium, lead, copper, and manganese. We've been focusing on sites around in Small Bay. We have data for the whole of Saldanha Bay, Langebaan Lagoon, Big Bay, Small Bay. I'm just focusing on these sites. The area, Small Bay, has always been our area of greatest concern because of the reduced circulation of water there, accumulation of fine sediment, and this is where the trace metals accumulate. The red dotted line here indicates the level of concern, where we expect that we're starting to get heavy metal toxicity for organisms that live in the sediments in those areas. And you can see these data are from the 1990s, so this is about 20 years worth of data from the late 1990s towards the present day. And you can see that there are some areas in Small Bay where levels were in excess, or for example for cadmium, levels were in excess of the safe limits in around 2005 to 2010. But in most cases, levels are now down and below levels of concern. Here, this is copper. Copper is a little bit of a concern in parts of Small Bay around the yacht club, where copper anti-fouling is used on some of the smaller vessels. Clearly a bit of a problem there, not so much elsewhere. Lead, again, a little bit of a problem around the multi-purpose terminal where lead has been exported. But again, a very encouraging positive downward trend in that area. Much effort has been put into better managing export of lead there, and that is being played out in the results. Lead levels and sediments are going down. Manganese there, I mentioned to you earlier, manganese, volumes of manganese, export of manganese started about 5 years ago. The volumes of manganese going out have been ramped up quite significantly in the last few years, but we don't see that playing out in the sediments. There's no clear indication of increase in manganese levels in the sediment. So again, means that that process is being managed well and not having a very negative impact on the bay. So again, looking quite good from a trace metal in the sediment perspective. Last thing I wanted to say about sediments is relating to erosion. Those of you that live here are familiar with the problems of shoreline erosion, of retreating shorelines. I've got some pictures of, this is Langebaan back in the 1960s. There weren't very many houses there in those days. But you can see what I want you to focus on is the beach profile here. That's Scarpin Island over there. This is the beach, what it looked like in Langebaan in the 1960s. After the construction of the ore terminal, you can see the beach has shrunk a little bit, but wind forward another 20 years, and we can see quite a massive reduction in the amount of sand on the beach there. You can see little inflection points there. This is efforts to try and control that erosion. The municipality has started to build berms there, and now 2021 you can see the two main berms on Langebaan Beach there and there have improved. There's a slight improvement in the amount of sand on the beaches there. These are profiles. So the Saldanha Bay Municipality, in conjunction with the Water Quality Trust, have been measuring the amount of sand, doing transects on the beach, measuring transects across the beach to try and understand and to get a handle on how the beaches change, how the beach profiles change, how the amount of sand on the beach has changed there. And what they've done is they separated it into North Beach, which is the section north of that black line that I've put in there, and South Beach, that's the piece of beach to the south there. This is the change over time, over 20 years, change over about 30 years at South Beach there above. So there's a 0 point over there, and this is positive above that 0 point, negative below that 0 point. And you can see in the 30 years or so, South Beach actually grew slightly and then has shrunk slightly, but pretty much the amount of sand on the beach south of that line hasn't really changed much since the 1970s. And if you look at the picture there, you can say it's pretty much exactly what it's saying there. Situation on what we call North Beach, this area to the north of this black line, has changed quite dramatically over the years. Starting in the late 1970s, shoreline retreated very, very dramatically. So there's the 0 point there. You can see the volume of sand on the beach dropped quite precipitously up until, I think it's around 2003 over there, reached a particularly low point. And we saw some loss of buildings, some loss of infrastructure at that time during major storms. There was some effort then that has been put in to try and control that erosion. I mentioned the groins, the two groins, those were constructed in, I think it's 2005 and 2007. Two groins went in there, had quite a dramatic impact. Some beach nourishment work that was done over here had quite a dramatic impact, where it basically recovered from that very low point up to here and has remained more or less stable in the last 10 years. So those interventions that have been put in place along those two stretches of beach have been successful. Unfortunately, we are quite a long way off where we were back in the 1970s, but at least it's stable now. Regrettably, the gentleman that was doing the surveyor that was monitoring those beaches passed away. I think it was 2 years ago, and we no longer have any data going forwards on these beach profiles, but hopefully we can see that being continued again in future, because I don't think this process of beach erosion is going to remain as favorable as it is at the moment, given the rising sea levels and increasing storm surges. Okay, moving on to marine organisms or the biota in the bay. I want to first talk about aquatic macrophytes. Sorry, Andre, I'm going to jump off the stage here for a minute just to grab a bottle of water. Okay, so talking about aquatic macrophytes. Aquatic macrophytes, it's a complicated term for plants that live in water or close to water. They have a strong affinity for water, and they only live in close proximity to water. And this is a new component of the State of the Bay work that we started quite recently. There was some historic work on looking at trying to understand aquatic macrophytes in and around Saldanha Bay. There was a student, van der Linden, from the Nelson Mandela Bay University back in 2013, used historical aerial photographs to be able to map reeds and sedges around the perimeter of the lagoon. And the results of that work come out as those sort of red patches where the student, based on those aerial photographs, they were she I think, was able to identify patches of reeds and sedges around the margin of the lagoon. These reeds are particularly important because they serve as a very important indicator of groundwater input into the lagoon. Most of these plants aren't able to survive in seawater. They want to be close to water, but they can't really tolerate high levels of salt. So they tend to proliferate in areas where groundwater is seeping out into the sea, and these plants are able to survive by virtue of the dilution of salinity that the groundwater provides. Which is why we're particularly interested in them, because we want to see to what extent we can use these to get a handle on groundwater outflow into the lagoon and how that might change in future. So we've been making some efforts over the last 2 or 3 years to try and monitor change in these reed communities. And we started using satellite imagery because satellite imagery is becoming much more widely available now. And our first efforts were a little bit dodgy. We used something known as an unsupervised classification system, where we took the data that van der Linden had generated, and we said, okay, assuming that everything that van der Linden marked as red as were definitely reeds and sedges on our satellite images, if we then program the satellite data using an algorithm, we say, okay, map for us everything that you think is reeds and sedges. And that came out with what appeared to be quite a dramatic increase in the amount of reeds and sedges around Langebaan Lagoon. The black outlined areas are those that van der Linden mapped as reeds and sedges, and the light green is what the satellite imagery told us was all reeds and sedges. And that suggested that there'd been a dramatic increase in the amount of reeds and sedges between when van der Linden did this work in 2013 and when we did the initial mapping in 2020. And we've since tried to refine our estimates, and what we did is send some people out in the field to actually go and look at spot measurements, where we sent someone out there bashing through the reeds, and each of those dots on the map there is the colored dots are, yes, confirmed reeds. The white dots are, there are no reeds here. And then we took that data, we looked at the satellite imagery, we interrogated the satellite imagery The satellite imagery comes in in color bands, so we can split that the information. Is the light that's reflected off the land that the satellite picks up comes in different bands, and what we can look at the different vegetation types, and we see that the reeds and sedges reflect light in very specific wavelengths, and if we combine the information from different bands in that light wavelength, we can then say, okay, all the colored strips there are reeds, and the white ones are other vegetation types. And if we translate that, we then interrogate our image. We can then map in much greater detail all of the reeds and sedges in the area around the lagoon. And then we can apply that historically. We've got good data. Satellite data comes in increasing frequency now, and we've got very good data, satellite data for the last 5 years, since 2016 through to 2021. And what we did is we interrogated the data for each year last 5 years, to try and understand how reeds and sedges are changing in the lagoon. So the red color there shows 2021, that's the latest distribution of reed cover in the lagoon. And the other colors, orange, yellow, green, blue, are going back in time. And what you can see there is that the reeds do seem to be shrinking over time. And what we're looking at there, 2016, this is a trend in time of the area covered by reeds in the last 5 years. And what we're seeing is quite a dramatic reduction in the extent of cover by reeds and sedges around the lagoon. Right now, we're looking at less than half, well, from around between 45 and 43 hectares of reeds back in those days, down to around 40. So it's about a 10% reduction in reed cover. We think that's most likely associated with the recent drought, that there's been reduced groundwater inflow to the lagoon, and we're hoping that that's not indicative of some longer term change. We don't think it's anything to do with groundwater use yet. We think it's most likely linked to the drought, but it does give us a good, it's a very useful way of measuring change in the health of the lagoon in that area. We've also been looking at some of the other vegetation types in the lagoon, just with this last State of the Bay report. Salt marsh, this is a spiky, sort of succulent-like vegetation that tends to grow in the intertidal area around the perimeter of the lagoon. And that also, the red here indicates it's got a unique spectral signature that we can identify from the satellite data. And from that, we can then map salt marsh distribution around the lagoon. It's also, the changes in the last 5 years have been mapped there, but what we're seeing is very, very little change over time. Okay, Andre says I must hurry up. Seagrass, very similar, tends to occur deeper, submerged in the water, but here we're seeing quite dramatic changes in seagrass distribution in the lagoon, which is possibly more concerning. Red, again, is the stuff where we're finding seagrass now. The green is where it used to be. And very dramatic changes we're seeing down there in the southern parts of the lagoon, and also up here. Massive reduction in the amount of seagrass in the lagoon. Not quite sure exactly why at this stage, but it's something we're wanting to keep a close eye on. Benthic macrofauna is something we've been looking at for at least since the last 20 or so years. Interesting patterns here. These are, the top row is numbers of organisms per meter squared. Bottom row is the biomass, and each column is a year's worth of data going back to the early 2000s. And this both in Small Bay, Big Bay, and Langebaan Lagoon. Some very interesting trends over time. What we're seeing is it seems like the abundance and the biomass of these organisms have been increasing right through that 20-year period. Not 100% sure why that is. We think it's a positive sign. Certainly, definitely increasing in Small Bay and Big Bay. Langebaan Lagoon a bit more noisy, but we think that's probably a positive sign and linked to the recovery we saw in sediments, where back in the early period, very high levels of mud around 2000, 2005, and that reduction in mud has led to a corresponding increase in biomass of living organisms in the sediment. So a very, very positive sign. There are a couple of anomalies in that data set. 2012, we saw a dramatic reduction in biomass at all of the sites, right from Small Bay through to Big Bay and Langebaan Lagoon. Not quite sure what that is. Same in 2008, there was a low point there. We don't know exactly what happened during that year. Maybe it was a major dredging event, something like that. But for me, long and short of it is, big smiley face, things are improving, and we're seeing massive improvements in the biota in conjunction with changes in the physical conditions in the bay. Rocky intertidal communities, these are organisms that live on the rocky shores in the bay. I've just got numbers of species over time. We've been monitoring these in detail since 2005. Interestingly, increase in the number of species over time from around 70 species back in 2005 up to over 110 species now. We know that alien species have contributed in part to that. We've picked up at least 5 or 6 new alien species in the bay over the years, and we know that alien species are dominating our rocky shores in the bay. A little bit more on alien species in the bay here. We try and focus on some of the more important species. This is data on this barnacle species that is dominating rocking shores along with the black mussel, and this has changed over time at a couple of sites around the bay. And for both of these species, we saw quite a dramatic increase from around 2005 up to a peak in around 2010-12, and then numbers going down again. Again, we think it's complex sort of predator-prey relationships going on here. This is a different little mole crab species that lives deeper in the bay. It's an alien species that came from North America, and this one seems to be expanding its range, particularly in Small Bay right now, numbers increasing quite dramatically in recent years. Sorry, I'm going quite quickly here, because otherwise Andre is going to come and throw me off the stage. Fish, numbers of fish and fish species in the bay. We're up to around 50 species of fish that we've picked up in Saldanha Bay through our surveys over the years. This year we caught 2 new species we hadn't caught before. The first was the snook, little baby snook that we've never caught here before, and the other is a panga, bringing it to, as I say, a total of around 50 species. These are numbers of species over the years since 1986 to the present day in Small Bay, Big Bay and Langebaan Lagoon. Bit of a concerning downward trend in the number of species present in Small Bay, but that is, I think, linked to changing conditions in Small Bay, increasing development, loss of shoreline habitat for these species. But thankfully in Big Bay and Langebaan Lagoon, lots of variation, but no long-term change with time. This is numbers of individuals, very variable in Small Bay, Big Bay and Lagoon, but no clear long-term trends. Birds. We have a lot of data on birds in Langebaan Lagoon and in Saldanha Bay. 2 major groups of birds. They are the ones that breed on the islands in the bay. There are 7 islands in Saldanha Bay, and this is probably 7 of the 12 or 15 islands around the whole country. These birds only breed on islands, so Saldanha Bay is enormously important for the populations of these species. And this data comes from 1975 through to the present day, collected by the Department of Forestry, Fisheries and Environment. Numbers of birds for many species initially showed a bit of an increase, but since then have been plummeting, and in almost all cases, the latest numbers are the lowest on record. Down from hundreds of thousands of birds now to a mere few hundreds or few thousands of breeding pairs on the islands. Very, very sad situation. We don't think that it's direct disturbance in the bay. We think it's mostly due to their food supply. This is populations or size of the sardine and the anchovy population, which very closely mirrors how the bird populations have changed over the years. A very, very sad situation. Birds in Langebaan Lagoon, that's the other really important bird populations here. These are the small waders, wading birds, mostly migratory birds, breed in the Arctic tundra, Russia, Norway, come here during our summer season to feed on the mudflats in Langebaan Lagoon. We've got data since 1976 for summer counts and winter counts done by the Animal Demography Unit at the University of Cape Town. And unfortunately, a very similar picture to the island breeding birds with decline in numbers over time. The different colors here, the red are the migratory birds. They're the ones that come out here. They breed. They don't breed here. They breed in the Arctic tundra. They come out here during summer to feed. The blue ones are the resident birds. So in summer, numbers are mostly made up of migratory birds. In winter, it's mostly the resident birds. The migratory birds have obviously suffered much more than the resident ones, which you can see from the difference between the winter and the summer counts. These are some of the individual species that we've been looking at: turnstones, plovers, sandpipers, knots. Something quite interesting has happened in the last year. You'll see that many of these numbers have suddenly jumped up in the last year. We think that's because of COVID, yes, and that less disturbance, fewer people trying to shoot or hunt these birds has led to a slight increase. And that increase is actually quite significant. It takes us back 10, 15 years back towards fairly significant numbers. And we really, really hope that may be sustained over time. So some light on the horizon there. People always ask me about seals whenever I talk here, so we've recently included some data on seal populations in Saldanha Bay. There are a whole host of seal breeding colonies all the way around the coast of southern Africa. This Cape fur seal only occurs in southern Africa from Angola up to our east coast there. There is one seal breeding colony in this area. It's on Vondeling Island, just over there. And we have data on numbers of seals breeding on Vondeling Island from around 2006 through to 2018, 2019. Fortunately, they weren't counted during COVID, but we've seen quite a dramatic increase in the numbers of breeding pairs on the island from around 1,000 breeding pairs back in 2006 up to around 20,000. And that's stabilized in around 2014 at around 20,000 breeding females on those islands. We think it's pretty much reached a carrying capacity now based on what food is available in terms of fish here. And it's very similar relative to the picture, the national picture. We decimated seal populations back at the turn of the century, 1900s. We managed to, because seals were extensively harvested for their pelts and for their meat, we managed to decimate our seal populations down to around 10,000 seals at the turn of the century. We're now at around 300,000 seals in the country, and populations are quite stable. So most of the seals you see inside Saldanha Bay are actually young males that are using the oyster rafts or the mussel rafts as roosting areas. But those ones that are breeding, the breeding females are mostly feeding outside the bay and are using the island there as a pupping area. You're pleased to know that this is my last slide, just to sum up on what we've been finding over the last 12 months. We can say that development, shipping traffic, wastewater discharge, visitor numbers have slowed in the last few years. But we are now starting to turn the corner. We are starting to see again increases in ore export, mariculture volumes of domestic wastewater coming into the bay are starting to increase again. Conditions in terms of physical and chemical conditions in the bay seem to be improving, or at least stable. Oxygen levels in small bay are a little bit concerning, but we're seeing a lot of positive signs there. I showed you positive signs: improving sediment quality, improving water quality. The biota seem to be responding quite favorably. I showed you trends in benthic macrofauna abundance, of how they've increased over the last 20 years. Fish populations are quite variable, stable in Big Bay and Langebaan Lagoon, maybe not so good in Small Bay. Seabirds in Saldanha Bay, unfortunately, seem to be still declining. Those in Langebaan Lagoon have improved a little bit. We know that marine aliens are still increasing quite rapidly, which is not great. But on the whole, I think for me, I'm seeing many, many more positive signs than negative signs here in the Bay. And I'm very encouraged by where we stand today, especially from all the indicators we're looking at. I think things are definitely improving, and I think we're doing well, and I think that's in no small thanks to the work that the Trust is doing. The industries in this area are doing, government officials, government responsibility. People are really taking their responsibility seriously here, and I think that's in a large part thanks to the work that the Trust does. So please keep on doing the good work that you're doing, and certainly don't take your eyes off the road.
Just tell me the Anglo-American initiative.
We recently had some discussions with Anglo-American. Anglo-American owns Kumba Iron Ore, and we recently had some discussions. They're looking at their focus on shipping and the export of iron ore, and they've taken a big interest in the risks and the impacts that shipping may be posing on the Bay. They've this year just joined the Water Quality Trust as a major contributor, and they're hoping to start to bolster some of the monitoring work we're doing on alien species in the Bay, which is very encouraging for me. So big thank you to them, and looking forward to fruitful partnership on that front going forwards. And thank you.